Good morning. This lesson is for my Honors Integrated 1 class, but before I get started, I want to say I hope that everyone's doing alright out there. I'm not sure how I'm going to title this, but I'm going to title it how I title in the title. But what I am sure of are our two goals for the day. And our first goal is going to be to investigate absolute value inequalities. Our second goal is going to be to solve absolute value inequalities. And let's just review a couple of things here really quick. Remember, absolute value is the distance to zero. And then I have a little table that shows us our inequality symbols. This symbol and this symbol mean left of. This symbol and this symbol mean right of. And if I have either of these two symbols, my circle is open, it's not part of the solution. And if I have either of these symbols, my circle is closed and it is part of the solution. So let's go ahead and jump into our first goal. And I guess we're going to do a combination of the first and second goal together, so I should put first and second goals. Let me fix that real quick, first and second goal. And we're going to do this twice, so there we go. First and second goal. I have an absolute value of x greater than 2. That, if I say it like that, it really means nothing to me. But if I try to translate it and use what I know absolute value is about, it makes a little bit more sense to me. And this can be understood as what numbers are more than 2 units from 0. Remember, absolute value means how far from 0. So we're interested in numbers that are more than 2 units away from 0. Or, you see that they're on the right further than 2. Right, but there are two sets of numbers that satisfy this. I have numbers that are on the right of 0 that are more than 2 units away. And I have numbers on the left of 0 that are more than 2 units away. So I have numbers that are left of -2 and numbers that are right of -2 that satisfy that absolute value of inequality. Now, what we can do is then combine our observational results to the original inequality that we have, and we have the absolute value of x greater than 2 becomes the two following inequalities. Notice I dropped the absolute value symbol, and on one side the inequality symbol flipped, and it became less than the opposite of the number, and the second one it stayed the same. Knowing that this can turn into this form, we can now solve absolute inequalities of the form absolute value of something greater than a positive number. It splits, whatever is inside remains the same. On one side it becomes less than the opposite of that number, and on the other side it stays exactly the same. So if we follow this format, we should be able to solve absolute value inequalities of that form. It's the same idea for greater than or equal or right of. Alright, so remember we must isolate the absolute value before we split. I'm going to show you now how to solve absolute value inequalities using this key observation. Alright, so I want to solve this and graph it. Now, my absolute value is isolated, so I am allowed to split. So I'm going to split it into two inequalities. And remember, whatever's in the inside gets written exactly the same. And first I flip the inequality symbol, and I change the sign of that number. So this is one possibility. This is describing the numbers on the left from 0. This other one will be describing the numbers on the right from 0. So x plus 4, again, this stays the same, and that's right of 6, and this also stays the same. So now I go about solving each of these individually, and I will know where my values are that make this true. Alright, so I would solve this one by subtracting 4. Those cancel. That means that the numbers I need to make this true must be left of -10. Let's solve this one. Those cancel, and I get the numbers right of 2 will also be the numbers that make that true. So let's graph this and see the numbers. So I have a 2, I shade to the right, and I have -10 where I shade to the left. So any number in the shading will make this statement true. So for example, if I plugged in -11 real quick, we would get the absolute value of -11 plus 4. Is that right of 6? Well, -11 and 4, that becomes -7. And the absolute value of -7 is 7, because 7 is 7 units. -7 is 7 units from 0. And -7 is right of 6 on a number line. So this is true. So this reinforces that any number on that side will be a solution. Same thing on this. If I was to pick, say, the number 3, if I plugged in 3, I would have the absolute value of 3 plus 4, right at 6. That becomes the absolute value of 7, which becomes 7, and now I'm back to where I was before. And again, any number in this shaded region would be the solution. So the numbers in the shaded area are the solution to this absolute value inequality. All right, let's work on the second example here. So remember, before we can split, we must isolate, and this is not isolated yet. So the first thing I have to do is I have to add the 5 to both sides. And now those cancel out, and I'm left with 3 absolute values of 2x plus 4 greater than 18. I can divide away the 3's. Those cancel out. Now I have the absolute value of 2x plus 4 is right over greater than 6. And now that I've isolated my absolute value, I can actually now split my absolute value. And so this is going to split into 2 problems. Whatever's inside stays identically the same. And we now flip that inequality symbol and change the sign of that. And whatever's over here, whatever's inside stays identically the same. And this also stays the same. Okay, so let's see here. So to solve this one, I'm going to subtract 4 to both sides. And I'm left with 2x is left of negative 10. I owe you 6, I owe you 4, I owe you 10. Let's divide away the 2. That means that the shading of the solution is going to be left of negative 5. This one, again, I start off by subtracting 4. And those cancel. I should cancel those. I'm left with 2x is right of 2. Divide away the 2. That means that any number that is right of 1 will also be a solution. And so let me graph this really quick. There's my 1. I shade to the right. There's my negative 5. I shade to the left. And if I was to plug in any values from this, it would give me a true statement. And that is how we solve absolute value inequalities for the greater than case or the right of case. So I'm going to clean this up, and I'm going to set up a situation to talk about what it looks like when we have the absolute value left of a number or less than a number. So again, let me clean all this up and I'll be back. I'm back. So let's go ahead and continue with this lesson. And remember, we're combining the first and second goal here. So the first run through, we had the absolute value was greater than a number. In this run through, we're going to see what happens when the absolute value is less than a number. And so let me translate what this means using simple terms. Because the absolute value of x less than 2, that means nothing to me. But if I think about it in terms of distance, it helps me to better understand what this concept is about. So this inequality is asking what numbers are within 2 units of 0? And that's a question, so I put a question mark. Let me get my grammar right. And we get the following graph. I get a graph with 2 and negative 2 that are my boundaries, and every number in between answers the question of what numbers are within 2 units of 0. And this graph is represented by the following inequality. Negative 2 is less than x, and that's less than 2. Okay? So the numbers between negative 2 and 2 are within 2 units of 0. Again, we can connect the original problem, which is this, with the graph and get a first step. So the absolute value of x less than 2 becomes the following. Negative 2 is less than x less than 2. Now, I got itchy nose. Now we can follow the format. The absolute value of something less than a positive number becomes the negative number less than whatever was in my absolute value less than the positive version of this number. And to solve our absolute value inequalities, so we're going to use this, we're going to follow this to solve our absolute value inequalities. Okay. All right. So again, we must isolate the absolute value before we rewrite. So I have 2 examples that I'd like to go ahead and solve and graph and show you how we use this format to solve when an absolute value is less than a number. All right. So the first example, my absolute value is isolated. So that means that I can rewrite it in the following format. And by the way, this also works for less than or equal to, okay? So again, this is isolated by itself, and so I can rewrite it in the following format. So I can take the negative number, or the negative of the number that's less than whatever was in here, so that's 2x minus 6, and that's less than my positive number. And so what we're going to do is we're going to solve all three at once. I'm going to add a 6 here, I'm going to add a 6 here, and I'm going to add a 6 here. That cancels out. I owe 10, I pay 6, that's a terrible plus sign. I owe 10, I pay 6. That means I still owe 4, and that's less than 2x, and that's less than 16. Alright, and so I can now divide away the 2. So you get divided by 2, you get divided by 2, and you get divided by 2. I get a negative 2, because 2 goes into negative 4 twice. That's less than an x, and that's less than an 8. So my graph is going to be bounded by 8, and it's going to be bounded by negative 2. And if I shade in there, these are all the numbers that if I plug into this, it's going to give me a true statement. So I'm going to pick the nicest number I can plug in. That's 0. 0 is a great number to plug in, so I'm going to plug that in to see if I get a true statement. 2 times 0, the absolute value of 2 times 0, minus 6 is that left of 10. I'm sorry I'm writing through this, I'll clean that out. Alright, well 2 times 0 is 0, 0 minus 6, I have nothing, I owe 6, that means I still owe 6. The absolute value of 6 means I'm 6 away from 0, so that becomes 6, and 6 is left of 10, so this is true. So this shading represents the solution to this absolute value inequality. Alright, so that's how I would solve the first example. Let's move on to the second example. I got such a mustache going to my nostrils, driving me nuts. Alright, so can I rewrite this? No, I can't, because the absolute value is not by itself. In order to make this by itself, I must first divide away the negative 3. Now, when you divide by a negative, you're changing the position of the numbers. And if you're changing the position of the numbers, you have to change how you describe where their position is at. So if somebody was on the left, it's now on the right. If someone's on the right, it's now on the left. And by the way, this is not the format that this section was about. So my 3 is divided out. I'm left with the absolute value of x plus 4. And that is now less than, because I divided by a negative, it's now less than positive 5. I've isolated my absolute value, so I can follow this format. I take the negative of that number, it's less than whatever was inside, less than the positive value. Okay, so this is now going to become negative 5. I should keep it blue. Negative 5 is less than my x plus 4, and that's less than my 5. And this is a real simple one to solve. I just take away the value of 4 to everybody. Alright. That cancels out. I owe you 5, I owe you 4, I owe you 9. 9 is less than x. That's less than 5 minus 4 is 1. So that means that my answer is going to be between the values of negative 9 and positive 1. So any number in the shading will be a solution to this absolute value inequality. So hopefully you understand how we came up with what the graphs look like for when it's less than, and for the previous section when it's greater than, and I hope you understand how we go about solving these things. So I'm going to go ahead and end this lesson here. I hope everyone is doing all right out there. Have a great day, everybody. Bye-bye.